So to find the sine of 35 degrees, 12 minutes, 44 seconds, first we'll make sure we're in degree mode, but if you already set it in degree mode yesterday, then your calculator should still be in degree mode. The only reason it would change is if you reset the calculator, or if the batteries died, or if somebody borrowed your calculator and changed it, but it shouldn't just be changing on its own. So I am in degree mode, sweet. So I press the sine button, and then 35, and you will find the degree symbol in the angle menu, which is second apse. Second apse. And notice it is there, it is number 1. And then you type in 12, because we want 12 minutes. Go back to second apse. Notice the the minute symbol is there. Select that. And then 44. I do not know why Texas Instruments did not put the second symbol in the angle menu. It's strange. The second symbol is above the plus sign, the double quotes above the plus sign, and to access it, you press alpha plus.
For a second.
Alpha plus. Okay? And that puts the double quotes there, which is the seconds. Okay? So the degrees and the minutes are in the angle menu. The seconds aren't. I don't know why. To get the second symbol, you press alpha plus. And then enter. There it is. I didn't have to use a protractor and draw out 35 degrees, 12 minutes, 44 seconds. I didn't have to draw a right triangle from that. I didn't have to measure the opposite side and the hypotenuse. The calculator tells me with a lot of precision what the sine is of 35 degrees, 12 minutes, 44 seconds. Question?
Where do you get the degree button?
The angle menu.
Oh, it's angle menu?
Yes.
Where's the angle menu?
Any questions on the first one? Next, I want to find the secant of 12 degrees. So, Julia, tell me what you know about secant. Cosine, yes. Good. Okay, so 1 divided by the cosine of 12 degrees is the same thing as the secant of 12 degrees. So the ratio of hypotenuse to adjacent in a right triangle with a 12-degree angle in it is 1.022 about. Try to keep the meaning of the numbers in mind at all times. Any questions on the second one? Next, Amber, could you tell me what to type to find the cotangent of 900 degrees, please?
You can do 1 divided by the tangent of 900 degrees.
Good.
You can't do that, so
Okay. 1 divided by the tangent of 900 degrees does not exist. It is undefined. As it says, divide by 0. And if you want to know why, whittle 900 down to an acute angle. So 900 minus 360 is 540, minus another 360 is 180. I could subtract again, but I'll leave it there. That is enough information I need. So think about 180 degrees. It's here. pick a point on the terminal side. For example, -1, comma 0. Tangent is y over x. So the y coordinate is 0. The x coordinate is -1. So the tangent is going to be 0. And you cannot divide by 0. Okay, any questions on that one? What's that?
Do we have to show you that work?
Only if I ask for it. And only if you cared. Not everyone cares. Okay, next one. We want to know, when is cosine -0.1? Random person. Sue, what should I type into the calculator to figure this out? Very good. Inverse cosine. And what button do I have to press? Very good. Second cosine of -0.1. You're undoing cosine. That's what it's doing. Enter. That is a degree measure. And you could prove that by doing the cosine of 95.74. And you'll notice it's about -0.1. Okay, any questions on that one? And Allie, could you help me find the cosecant? Oh, excuse me. Can you help me find when cosecant is 2.5? Okay, so tell me what you know about cosecant. It's the hypotenuse over the opposite. Okay. Allie, is it possible for the ratio of the hypotenuse to the opposite to be something like 2.5? Yeah, because the hypotenuse has to be the longest side. Okay. Now, I need to use an inverse trig function, like Sue advised us to use in the previous problem. The issue is that I don't have an inverse cosecant function on the calculator. I do have an inverse sine function on the calculator, though. And since cosecant is the reciprocal of sine, I can use that to answer this question. So sine of the angle is the reciprocal of the cosecant of the angle. So it's 1 over 2.5. Anyone, what's 2.5 as a fraction?
3 over 2.
It is not 3 over 2. It is 5 over 2. Flip 5 over 2. 2 over 5. Okay, so the sine is 2/5. Now you can go to the calculator and do inverse sine of 2/5. Second, sine 2 over 5. There you go. That's the angle. So if I heard you correctly, you could do the inverse sine of 1 over 2.5. Absolutely. Okay? Any questions on any of those? So let's say you wanted to test if the equation number 17 was true. You could do sine of 180 plus 45, as it says, and then you can go to the test menu. No, it does not give you a test. It's used to test things. Second, math. And notice we have an equal sign there. Let's insert that. And now let's type the rest, although we do have to use parentheses. Sine 180 close paren times cosine 45 close paren plus cosine 180 close paren times sine 45. And then let's hit enter. It gives us the number 1. Guess what that means? It's true.
Had it not been true, would it have said error?
If it was not true, it would give you 0. And from what start? Oh. So we can just make sure that the calculator is doing what we want it to do and just verify that this is accurate. So the left-hand side is negative 0.707, which looks like negative 1 over root 2. Okay, and then on the right, I'll do sine 180 times cosine 45. That's 0. And then cosine 180 times sine 45. That's that. Yep, that is a true statement. Okay? 1 is true, 0 is false. 3. Okay, grade resistance is the amount of force that a car or some object encounters due to a grade, which is either an incline or a decline. If you notice a negative angle, what that means is that you're on a decline, or you're going downhill. The maximum grade resistance would occur when you were trying to travel up a vertical wall. Check out my sick ride. It's very symmetrical. 90 degrees equals the most grade resistance that you would feel. And it actually would be the entire weight of the car. And if you look at the formula for grade resistance, it's F equals W sine theta. W is the weight, theta is the angle. And if you plug sine of 90 in to your calculator, you get 1. And that is the highest value that sine can be. It has to do with the fact that the hypotenuse is in the denominator. So it restricts that number. It can't be bigger than 1. So this is the highest when theta equals 90, since that's the highest value of sine, or that corresponds to the highest value of sine. The lowest value. What do you think? What's the angle going to be? When the grade resistance is the lowest value. Oh, that's a good point. I forgot to think about that. So let me rephrase. Let's say you're not going downhill. 270, that wouldn't actually exist, because that would be like going straight down, and that would not even exist in a triangle. But I could understand why you might say that. So you can't go down. A straight across, like a straight line, like a flat plane. Stick with your day job, Johnson. Don't become an artist. Okay, 0 degrees leads to the lowest grade resistance. And what's the sign of 0 degrees? Sign is never undefined. It's 0. So if you plug 0 into this equation for sine, what do you get? 0. Or no grade resistance. Which makes sense. You're not on a grade. So that's going to be the lowest value. Yes, I know you can go downhill. So aside from going downhill, that's the minimum grade resistance. All right. So I showed you one yesterday. Let's see if you remember. Dominique, could you tell me how to solve number 23, please? You're looking at 22. Yep. Okay, so it's a very simple equation. The grade resistance is the weight times the sine of the angle. Negative 261, very good. What units is it in? Pounds, yeah. What do you think a negative grade resistance means? Well, yes, and what else? It's not working against the car, it's actually, yeah, it's actually helping the car. Yep. Or a 261-pound support. This is another way to think about it. Great. If you want to do anything with physics, if you want to build things, if you want to design buildings, if you want to design automobiles, planes, anything with electricity, trigonometry is going to be key. And I say that from experience. But if you want to work at Chipotle, I don't think you'll need trig. (24) Val. Set it up, please. Uh-huh. And we don't even need to use our calculator. What's it going to be? Think about what I said before. If a car is on a plane, a flat surface, there is no grade resistance. Okay. A 2,550-pound car has just rolled off a sheer vertical cliff. Okay, what's the car's grade resistance?
This is not counting for the fact that there's like a downward slope and cut roll, right?
I don't think it matters, but I could be wrong. So I expect it to be the entire weight of the car. And I know that the sine of negative 90 degrees is negative 1.
Going down.
Yeah, because it's negative. Yes?
And that's all sine.
Oh, that's a good question. I tried to figure that out yesterday, and I don't have an answer yet, but I'm working on it.
What about all sine?
When you're working with grade resistance, it's always going to be sine. And as soon as I figure it out, I'll let you know. But because the book doesn't explain. Okay. Snell's law. Let me at least introduce it to you. Does anyone here use Snell's law in their science class? Okay. Yeah, it's a common formula that's used, I would say, in high school science. It has to do with physics, and in particular light. How light refracts or bends when it passes through different mediums. So the speed of light is not the same for all mediums or media. It's one thing in a vacuum, it's a different thing in water. Okay? In which is it going to be faster?
The vacuum.
In the vacuum. Yeah, because there's nothing there that's blocking it, right? Okay. So this is what happens. Okay, so this is the threshold. Over here you have medium 1. Over here you have medium 2. So this could be air, this could be water. And this is the light path. Yeah, anyone who thinks that math and science is boring hasn't actually done math or science. You might think it's boring because of the way it's presented in school, but if you actually do math and science and you're bored, please tell me. Okay. So this is the first angle. This is the second angle. And you're going to have a speed of light here. That's going to be c1. And a speed of light here. That's going to be c2. Snell's law is pretty simple. The ratio of the speeds of light is equivalent to the ratio of the sines of the angles. So for the first one, we're trying to figure out the speed of light in the second medium. Well, you need to know the speed of light in the first medium. It's 7 times 10 to the 9th. It's probably meters per second, but they don't tell us what it is. And then the angle 1 is 44 degrees. And the angle 2 is 33 degrees. Is this the equivalent to the sine of 11 degrees?
No.
No. I've seen that done. So then you just cross multiply.
Well, are you allowed to reduce?
How so?
If it was 44 over 22, could you take out 11?
No. Because these are angles that are being operated on by these functions.
Also, if it was 2 sine over 4 sine, then you
That's different. That can be simplified. And then divide both sides by sine 44. Okay, 7 times 10 to the 9th is that, times sine 33 is that, divided by sine 44 is that. 1, 2, 3, 4, 5, 6, 7, 8, 9. 5.49 times 10 to the 9th meters per second assumed. Good timing.